Okay, day 3 notes. Can you look? We're going to start making the transition now into actual geometric proofs. So we're going to review Algebra 1 again, real quickly. You know how to do this. So we have, we're going to start off with our T chart, and this is always going to be reason. Okay. Remember, it's like a 3-year-old. Every time you do something, you're going to ask why. Why? So we have 2x plus 6 equals negative 2 times x minus 4. And our goal is to get x equals negative 1. Now, there's a couple things we can do here to start. But I'm just going to, there's not multiple ideas. But I'm going to send my 2 and my negative 2. I'm going to distribute. And every time you know that from algebra, you say that, that's the same thing you're going to use. So this ends up being 2x plus 12 equals negative 2x plus 8. Because negative times negative is positive. And what does the 3-year-old say? Oh, I'm sorry. We're going to say this. Given. Why did you write that? Why? Given. That was given to us. So what do we do right here? Why? Distributive property. Okay. And now I'm going to, you can move your numbers or your variables. It doesn't matter. I'm going to add 2x to both sides. And then the 3-year-old says, why? Because I can, with the addition property. As long as I add the same thing to both sides, I'm fine. What I'm left with is 4x plus 12 equals 8. And so I move my letters to my left side, I'm going to move the numbers to the right side. So I'm going to subtract 12 here, subtract 12 here. 3 over goes y, plus subtraction property. It allows me to subtract from both sides. Which gives me 4x equals negative 4. And now I'm going to divide by 4. Y, division property. And now I have my answer. I have proven that x equals negative 1. So, let's get into geometric proofs. We're going to use a similar format to prove different things in geometry, theorems and statements. So first we're going to review some things. So we're going to name the transversal. Well, transversal is, it's like R. Maybe it's an L. Who knows? We're going to call this R. It's kind of blurry. Even on the paper, it's kind of small. But we're going to call it R. So R is the transversal. Okay? And the vertical angles, well, they're kind of messed up here. So I apologize. It's got screwed up. So if it's printing your book wrong, please fix this. And the 3 and 4 are here. Then we have 5, 6, 7, 8. So, vertical angles are 1 and 4, opposite each other, 2 and 3, 5 and 8, and 6 and 7. Those are the ones that are opposite each other. Corresponding angles, remember, 1 inside, 1 outside. So that's going to be 2 and 6. 2 is outside, 6 is inside. 4 and 8. 4 is inside, 8 is outside. 1 and 5. 1 is outside, 5 is inside. And 3 and 7. 3 is inside, 7 is outside. Now, alternate interior. Remember, those are going to be on opposite sides of the transversal. So that's going to be 4 and 5. alternate exterior, just like alternate interior, but outside. So 2 is with 7, and 1 with 8, because they're on opposite sides of transversals. Moving up, back up here. We talked about this the other day. When lines are parallel, and this is the symbol for parallel lines. Okay? We have these different symbols in math. You know, when we want to show that these two are congruent and these two are congruent, we use the hash marks. Okay? And we want to talk about angles being congruent, we use the arc marks. Well, the way to show parallel lines is these triangles. Some people color them in, some people don't. Either way is fine. And you can use one triangle or two triangles, just like the hash marks. But here we're saying that these two lines are parallel. Well, we spoke about this the other day. When you have parallel lines and you have a transversal cut through it, very special things happen. If the lines are parallel, alternate interior angles are congruent. Okay, alternate interior, so 4 and 5. You remember we talked about in the previous video, we talked about 4 and 5 being acute angles, and 3 and 6 being obtuse angles, and they are actually congruent. In fact, all of the obtuse angles in this situation, 2, 3, 6, and 7, are congruent. And all of the acute angles, 1, 4, 5, 8, are congruent. So if the lines are parallel, corresponding, 1 inside, 1 outside, think about it, 2 is outside, 6 is inside. Remember I talked about the elevator, okay, or the zip line? Then this situation, these are the same. Okay? So again, congruent. Same goes for alternate exterior angles. Okay? 2 and 7. They're also congruent. And if you think about it, it all makes sense. Because if 2 and 6 are congruent, right? And 6 and 7 are congruent because they're vertical, that means 2 and 7 are also congruent with the transitive property we talked about. If 2 equals 6 and 6 equals 7, then 2 equals 7. Now we don't need to do that because we also have the rule of alternate exterior angles, but that's why they are congruent. You can prove things many different ways in geometry. Okay, so now we have this very busy drawing. We have ABX going one way, and we have CD going a different way. And every line is a transversal because every line is going through two lines. Watch. 1, 2. 1, 2. 1, 2. 1, 2, 3. 1, 2, 3. So therefore, every one of those is a transversal. So we're going to write a proof, and we're told that A is parallel to B is parallel to X. Okay, so A, B, and X are all parallel. So they don't give you the triangles, but they're telling us in the given that these are parallel. And we also know that C and D are parallel. We have to use a different number here. Okay? But they weren't marked like that, but they're telling us it's given in the proof. That's what we're starting with. And we're going to prove that 11 and 18 are equal. This one right here, and this one all the way down there. So let's go. That reason. And we're going to write down A is parallel to B is parallel to X, and C is parallel to D. And those are both given. Now, we're going to look at the picture, and we're trying to get from 11 to 18. So we're going to travel down here first. Okay? And we can also almost ignore A. Like pretend that's not there. Okay? And we just have B and X, and here's D. And we're looking at 23 here and 11 here. Just try to clean it up a little bit. And you can always do this. You can simplify the drawing if there's too much going on. What do we call these angles? One's outside and one's inside. And again, if the lines are parallel, we have the escalator, right? Or the zip line. What do we call these? We call them corresponding angles. So we can say that angle 11 is congruent to angle 23. And the rule is corresponding angles. So it's a little wordy, but you should technically say something like corresponding angles are, and you can use symbols, congruent if lines are parallel. You can use symbols, and you can even, if you wanted to, like abbreviate chorus. Okay, especially since I've got the D here, corresponding. So corresponding angles are parallel if lines are parallel. And they're congruent if lines are parallel. You can also say if lines are parallel, corresponding angles congruent. It doesn't matter which order you do it in. So we just proved that 11 and 23 are congruent. Okay? And now we're going to say, look at this one. Here's 18, right? Well, 23 and 18, what do we call those? Well, they're on opposite sides of the transversal, and they're outside these two lines. So those are alternate exterior angles. And we just learned that those are congruent. So we can now say that angle 23 is congruent to angle 18. And once again, we can say if lines are parallel, or we can say alternate, we can abbreviate, exterior, abbreviate, angles are congruent if lines are parallel. And you can use all the symbols you want in abbreviations. And if you want to start off by saying if lines are parallel, alternate exterior angles are congruent, that's fine also. So we've just proven that 11 is the same as 23, corresponding, and 23 is the same as 18. And now we're going to use that, what we talked about earlier, that transitive property. Since 11 is the same as 23 and 23 is the same as 18, we can now say that angle 11 is congruent to angle 18 by the transitive property. And you have just proven your first geometric theorem, or concept, statement, sorry, losing words. Okay? Now, we're going to do another one. Last one. Given that A, B, and X are parallel, and C and D are parallel, prove 5 is parallel to 21. So again, reason, and we say A is parallel to B, is parallel to X, and C is parallel to D, and those are given. Now, let's go back and look. We're trying to prove that 5 and 21. So let's find those. 5's here, 21's down here. Now, we have it 3 different ways we can go, okay, to prove this. But we know that 5 and 17 are corresponding. One inside out, one outside. When I say that, I'm saying let's just look at these two lines and this transversal. Once again, we need to do this. Let's say here's 5 and here's 17. Kind of clean it up. You can go off the side of your paper, that's fine. But 5 and we know that these are parallel to each other. That was given to us. So since they're parallel, we know that corresponding angles, one in, one out, are equal to each other. They're congruent. So we can say that angle 5 is congruent to angle 17. And we can say corresponding angles are congruent if lines are parallel. Okay? And now we can say 17 and 21, what are they? Well, again, one inside and one outside. 21 is in between C and D, 17 is outside C and D, and we're looking at the transversal of X. So therefore, 17 and 21, angle 17 is congruent to angle 21. And where the little kid goes, why? Because again, same reason, corresponding angles are congruent if lines are parallel. And now we can say that since 5 is congruent to 17 and 17 is congruent to 21, we can say that angle 5 is congruent to angle 21. Move this down so we have room. And it says why? Again, the transitive